Welcome back. In this session, we continue with the discussion on realization of discrete time systems. Now, in the previous session, we realized the discrete time system by using the general anatomically difference equation, and then we took the transfer function. We tuned the transfer function out that, like this, and the transfer function looks like dkv from 0 to m divided by 1 plus summation k from 1 to m a k 0 minus k, right? And we realized that this system by this structure. And by this structure, we saw this in the previous class. We saw this in the case. We realized it like this. Now today what we are going to do, we will interchange these terms, these zero terms and whole terms. Let's see what will happen to the structure. So let me write it like this. So we can write it like this: summation k running from 0 to m bk 0 prime minus k multiplied by 1 by 1 plus summation k running from 1 to m ak 0 prime minus k. Alright, what we have done, in short, we have separated the zero terms and whole term, right? That's what we have done. So let me call this transfer function as hz of z, and this one as let me write it as hp, right? Let me write it as h. What is hp of z and what is hz of z? Hz of z means this is simply summation k running from 0 to m bk 0 minus k, and h p of z means, which represents the pole part, 1 by 1 plus summation k running from 1 to m ak 0 minus k. Alright, so we have done anything. Now what we'll do next, we'll say y of z is the output, x of z is the input, and y of z by x of z is now given by hz of z and multiplied by hp of z, where z of z is this, hp of z is this one, right? So what we'll do, we'll say yz of z can be written hz of z multiplied by hp of z and x0 z. This is the input in frequency domain, this is the output in frequency domain, and these are the transfer functions, two transfer functions. So in block notation, how we can write it like this? So as a block, we can say this is one block, and this is another block, and if we connect these two in cascade, then the overall transfer function will be hz of z, sorry, and this will be h of z multiplied with hp of z, then the input to this is x of z, and the output of this whole system will be y of z, right? So this is how we can realize this system. So what we will assume that there are two systems actually, one whose transfer function is z of z, another whose transfer function is p of z, and let's suppose the intermediate output is wz in frequency domain, right? So when the input to the first block is a x of z, the output is wz. So how we will write wz? Wz will be simply as x of z means input multiplied by the transfer function of the system, right? Then the output, final output is y of z, which is the input. Now the input is wz multiplied by hp of z. Now remember, let me repeat it again. To compute the output of any system in frequency domain, just multiply the transformer of the input, transformer of the transfer function, that will give you the transformer output. Now substituting the value of this here, that will be x of z, h of z by zz, and hp of z. Isn't it the same? Isn't the same? whereas g of z is this and hp of z is right. So we haven't done actually anything, but we have only separated the two transfer functions into two blocks or two systems. All right. Now let us concentrate on this equation and then on this equation. So let me concentrate on this equation first. All right. So WZ is what is WZ? X of Z, H of Z are zero, right? Now that means WZ by X of Z. We write it like this: it's HZ of Z, and let me substitute the value of HZ of Z. This is summation K running from 0 to M, BK 0 is power minus K. Then substituting the value of expanding this summation, this will be B0 0 is power 0, B1 0 is power minus 1, B2 0 is power minus 2, so on up to Bm 0 is power minus m. Alright, now transferring this x on the right hand side and multiplying it with each term, this will be Bz x of z plus B1 0 is power minus 1 x of z plus B2 0 is power minus 2 x of z plus so on Bm 0 is power minus m x of z. What we have done in this step, we have transferred this term on the right hand side and multiplied it with each term, right? We have done actually anything. Now taking the inverse z transform here, taking inverse z transform here, what will be the inverse z transform of wz? It will be wn simply. So this is wn. What will be the inverse z transform of this? B naught is constant. This will be x of n. What will be inverse z transform of this using the shifting property? It will be b1 x of n minus 1. If the inverse z transform of x of z is this, then inverse z transform of z inverse x of z is x of n minus 1 using the shifting property. B2, then this will be x of n minus 2 again using the shifting property, plus so on. Then this will be Bm x of, sorry, not z, m, x of n minus 2. So this is our equation. So this is Wn, right? This is Wn. Then, and this is our equation now. Now, y of z is equal to Wz multiplied by hp of z, right? From this here, from this here, right? From this cascading system, from this cascade system, right? So substituting, so we can write Wz by yz by wz is equal to hp. So this will be 1 plus summation k running from 1 to m a k 0 is 1 minus k, right? So this is our actually second system. And this is our second system. So this is hp of z, and the input is wz, and output is yz. I'm just writing this. So rearranging the terms, we'll write yz plus yz summation k running from 1 to n a k 0 is minus k is equal to wz, right? So expanding this summation again, first taking it on the right hand side. We take this on the right hand side, this is z minus yz, and expand this term. And so let me write down, let's expand it in the next step. So this will be ak z minus k. So this will be wz minus yz. Now expand this term. So this will be a1 z inverse minus 1 plus a2 z inverse minus 2 plus a3 z inverse minus 3 plus 1 plus an z inverse minus 8. Right now multiplying, now we have by y of z, we get wz is equal to minus a1 z inverse y of z minus a2 z minus 2 y of z minus a3 z minus 3 y of z minus 1 up to a and 0 is power minus n y of z. Now again taking the inverse z transform at this. So again taking inverse z transform here, what we'll get. So the inverse z transform of y of z will be y of n. Inverse z transform of this is suppose y of n wn. So what will be the inverse z transform of this? Again using the shifting property, it will be y of n minus 1. Shifting property here, it will be y of n minus 2 minus a 3 y of n minus 3 minus so on up to a n y of n minus, right? So this is our equation 7. Now have a look at equation 1 and equation 2. So have a look at what is our equation 1. So our equation 1 is here, and this is our equation 7, right? Now just looking at these two equations, it seems there are two different equations of the Wn. There are two different equations of Wn, right? One equation is for Wn, one equation is for y of n, right? One equation is for Wn, one equation is for yn. In fact, there was only one equation when we started with the general difference equation. If you remember the difference equation, our general difference equation, that was y of n is b naught x of n plus b1 x of n minus 1. Sorry, this minus 1 plus on bm x of n minus m minus a1 y of n minus 1 minus a2 y of n minus 2 minus 1 up to an y of n minus n, right? So this was our general difference equation. And we take the z transform of this, then we arrived at this expression, right? So even though we started from the one equation, but we are arriving at two equations, right? So there are two, one is for wn, one is this y of n, but actually these are one and the same equation, although one equation seems for x for wn, one equation seems for this y of n. This actually, this equation is the shorthand note. If you substitute this here, this is one, this will become this equation. Have a look at this. So if you substitute wn here, you will get this expression back. So if you substitute wn from equation 1 to equation 2, you will get the same equation back. But what's the aim here? Aim is to first realize this system, then realize this system. That's the only aim here. All right. I hope you got the idea. So the aim is first realize wn, then realize this part, right? So if you substitute wn here, you will get this expression back. We haven't done anything. We just want to this realize these two parts separately. All right. So let me redraw the expression here. Right. So our wn equation is, where is wn? This is our wn equation. Our wn equation is b x of n b1 x of n minus 1 plus b2 x of n minus 2 so on bm x of n minus. So this let me first get this. Let me realize this term. So let's realize this expression first. So this is our equation. Yeah. All right. So let's do this first. So let's start with x of n. Suppose we have input is x of n and our output is wn, right? Our output is w, right? So first what we'll do, we need this term, right? x of n, b of that is multiplied by b of 0, and then we get b naught. Let me write it like this, b naught x of n. Then we have to add with this term, this term. First I must get x of n minus 1. How do I get x of n minus 1? We delay x of n by one sample point. We delay it. Then the this is delay symbol, and here we have x of n minus 1. Then what we'll do, we'll pass this through again a multiplier whose multiplying coefficient is b1 here, and add this what we have b1, which we use marker b1 x of n minus 1, right? Then what we'll do, we'll to get the third term, means to get this term, we'll again delay x of n minus 1. That will give us x of n minus 2. So that will give us x of n minus 2. So here now we have x of n minus 2. So what we'll do into this, we'll again pass through this multiplier block whose multiplying coefficient is b2. So add this, what we have b1 b2 x of n minus, right? And this will continue this way, will continue this way. Finally we'll reach to x of n minus m when we have m of element at, so when we have m of element at this. Alright, so when we have m of element 0 is minus 1, so the output of this will be x of n minus m. So what will be this output? What will be this output? This will be actually x of n minus m minus 1, right? So if you want to multiply this, you can multiply this with b of n minus 1, and when we multiply this, we say we pass it to an element multiplier or element whose multiplying coefficient is b of m, then the output of this will be b m, right? Okay, so our goal is to add this. So what we are going to do, first we will add this to this. So what we'll do, we'll add these two elements, means the last two elements. So we'll add these two, then whatever is the output means before this term, then I will add to this term, right? So we'll add to this, then we'll add this to this. Whatever is the past output, then we'll finally add whatever we have arrived at, we'll add this. So this is how I obtain the terms. So this is how we obtain the terms here, how I have obtained this. Please pay attention. So to add this one and this one, what I will do, I will use a summer. So I am using a summer. I will add this to this. Then I have to add this sum to the previous this block, right? That's what I'm doing here. This block, suppose this is available here. Then so on. Or I can start in the other way direction. So I can start with this bmx of n minus m. Then the previous value that is here. That is here. So adding that and continuing this way, I will arrive at Wn. So this is the first equation. Now to realize the second equation, that is this. To realize the second equation, this part, what I will do, we'll say we have y of n here, right? So what to realize y of n minus 1, what we'll do, we will delay this. So we'll delay this y of n. What we have here will be having y of n minus 1. Then what we'll do, we'll pass this through a multiplier whose multiplying coefficient is minus a1, right? Then we'll again pass y of n minus 1 through a delay element, right? Then the output will be y of n minus 2. Again, we'll pass this y of n minus 2 through a multiplier whose multiplying coefficient is a2, minus a2, sorry. And then we'll again pass this through a delay element to obtain this term. Actually I used to obtain this term. So here we have y of n minus 3. Then what we arrive at, we pass this through a multiplier whose multiplying quotient is a of minus a3, and we will continue this procedure till we arrive at this last term, right? So the last term will be y of n minus capital N. So what will be this input? What will be this input? That this input will be y of n minus n minus 1. Remember that, right? So this will be the input before this. Then what we'll do, we'll pass this through a multiplier whose multiplying coefficient a of minus n, right? So I have these available. Let me rearrange this first. So what is the output at this? Let me write that, right? So here I have minus a1 y of n minus 1, right? Here I have, sorry, let me not do it like this. This will seem there is one more input output going like this. So this here I have minus a2 y of n minus 2. Here we have minus a3 y of n minus 3, and so on. Here we have minus an y of n minus capital N. And if I represent the input that is before this, means if I represent the input that is before this, I can write it like this. So we can write it as minus a of n minus 1, actually y of n minus 1. Alright, please try to understand this. Then what we'll do, how do I add these terms? How do I add these terms? Adding using a summer, right? Using a summer, first to adding these two terms, then adding this to the next, adding this to the next, and so on, and continuing this way, you will have the second equation. So this is the summer. So adding this to this, then I will add this to the next previous term, right? Then adding this to this term. So I will add this to, please remember here is dash dash. We don't know where is the end. So please use this. So then we'll add this. And finally, whatever we have realized, I'll add this to this. And this is this part, right? So this will give me this part. This will give us this part. Now then we'll add finally Wn, that's realized here, and we'll say this is the input of this, and that's how we realize the whole system. That's how we realize the whole system. And have a look at this. Here we have realized only zeros part, means all zeros. Here we have realized all poles. And this structure, in which on the left hand side we have all zeros, and on the right hand side we have all poles, this is referred as direct forum structure. This is referred as direct forum one structure of the discrete time system. So this is referred as direct forum one structure of a discrete time system. Right? I hope you understood how we arrived at this procedure. We first separated the poles and zeros. We wrote first zeros, then poles, right? And then we realized this system. Now in the next session, we'll see if we first write poles, then zeros, what will happen to this expression? What will happen to this expression? So if we first realize the poles, then zeros, what will happen to this system? All right. So that we'll do in the next session. Let me end this session here.